So let's do some examples about solving linear inequalities. Let's say our first example involves an equation like this. If we add 10 to both sides, we end up with x being greater than 3. As a set, we could say it's anywhere from 3 to infinity. As a number line, we would put an open circle or a soft bracket on 3 and say we want anything bigger than that. Or if we're given something like 4x plus 1 is greater than or equal to 5x, subtracting 4x to both sides, we end up with x less than or equal to 1. So hard bracket, anything less than is what we want. In terms of a set like this, we would say anything before 1 is from negative infinity up till 1. Hard bracket, because we can also be equal to 1. So going further, let's say we had 8x is greater than or equal to negative 40. Divide both sides by 8, just like if this were an equal sign, and x has to be greater than or equal to negative 5. We could put this as negative 5 to infinity, hard bracket, because of the equals portion. If we were to put this on a number line, we can draw it to look something like this. Thing to note is if we are dividing by a negative, so for example in this case, dividing both sides by a negative means in inequalities it flips the sign. So instead of greater than, we have a less than symbol. Negative 60 divided by negative 20 is 3, and x, anything less than 3, so anything from negative infinity up till 3 would count. And we could produce a number line to show that same representation. Inequalities can go as far as something like this. We can have negative 2x plus 8, 5 minus negative 2x plus 8 is less than or equal to 11 minus 4x. We can basically have equations that look similar to if we had an equals but with an inequality. So 5 plus 8 is 13 minus 2x, adding 4x over, subtracting 13. So we get 2x is less than or equal to negative 2, x is less than or equal to negative 1. So negative infinity up till negative 1 would be our solution set. And because we divided by positive, sign stays the same. Well, these can become even more complex if we start adding in things like this. So 3-part. In this case, when I add 2 in the middle, I have to add it on all sides. So x would be less than 5, but greater than 1, and we would say from 1 to 5 is our solution set. And on a number line, we'd have 1, 2, 3, 4, 5. Let's put some numbers on the outside just so we can show how this works. So we'd 1 soft bracket, 5 soft bracket, anything in between. One last example. Say we have negative 2, negative 4x minus 5 less than or equal to 7. Adding 5 means I'm going to add 5 to all 3 sides. So negative 4x is less than or equal to 12, but greater than 3. Dividing by negative 4 means signs are going to flip. So we have x in the middle, flipping this sign, flipping this sign. 12 divided by negative 4 is negative 3. 3 divided by negative 4 is just negative 3/4. So x has to be less than negative 3/4, but greater than negative 3. So if we're looking at a number line, we end up with this. Or as a set, negative 3 to negative 3/4.